Hi everybody! Today we're talking about circuits, and now we're going more in depth about what's the difference between series and parallel. So we're going to look at both, and not just what you learned a long time ago. Oh, when light bulb turns out, they all go out because it's series. We're going to go more into the calculation. We're going to understand where the current goes and understand more with our calculations and resistance and everything else. So that's what we're covering today. Okay, so let's talk about this circuit here. This obviously is a series circuit, right? And if you can think of it a couple ways. If you put your thumb over a resistor, or you block this out right here, well then everything should block out. There should be no current that can flow, because if you had current running through this circuit right here, kind of like a bridge being washed out, there's no way to get across the other side, so the current could not flow through. Okay, so that is a normal series circuit, which you've probably seen before. Now, a few other things. So that's when we talk about with current, that the current only has one pathway, right? There's no splitting up. There's no other branching off with a series circuit. We already talked about the light bulbs. Now, here's something different. The voltages are going to add up. Okay, and the voltages can be different across each resistor. So I have a resistor here and a resistor there, right? Well, both of these can have different voltages. So let's say I have, 12 volts right here. So if I have 12 volts for my battery, these two resistors are going to add up to that 12. Now, it could be 6 and 6, but it could also be 8 and 4 volts. Okay, 8 volts plus 4 volts will have to add up to the original 12. All right, so that's one thing. Voltages will add up to the total that the battery is given. Now, what about our resistance? For all circuits, we usually want to redraw any circuit into just one resistor, one simple circuit, okay? Because that's going to help us figure out more things, like figure out the current leaving the battery. So if I were to redraw this, let's make up some numbers here. Let's say that this is only 2 ohms, so I'm going to do a different color so we don't confuse it. So let's say this is 2 ohms right here, and this is only 1 ohm. Okay? Well, if I were to redraw this circuit into one simple circuit like that, well, I would add them up. 2 plus 1 means this is the same as having only one 3 ohm resistor in a simple circuit. Okay, so it's very, very easy in series circuits. Parallel is going to be very different, okay? But in series circuits, if I had a lot of resistors that are all in series, you just add them all up. So that's what that equation shows. All right, now let's move along here. So again, a quick reminder, the current will go through. So the current will stay the same. So I talked about the voltages are adding up. 8 volts plus 4 volts adds up to your 12 volts, okay? Well, current will stay the same. So if I have 1 amp leaving this battery, everywhere here, there's no splitting up anywhere in it. So that means there's going to be 1 amp going through this resistor and 1 amp going through that resistor. Okay, so let's think about this and put this in perspective so that we can make a statement about series circuits and then compare it to parallel circuits. So in a series circuit, okay, the current will stay the same throughout, and the voltages will add up to the total, as in the battery. Okay, so I'll say it again. In a series circuit, the current stays the same throughout, and the voltages add up to the total. Now let's go back to that picture again. Notice how the currents stay the same. 1 amp left the battery. That means 1 amp goes through the resistors, and it stays the same throughout. But the voltages, we had 8 volts and 4 volts, they added up to the total of 12. So that's our statement for series. Now let's compare that to what we're going to talk about with parallel. With parallel, notice the blue and the red, those are just going to get swapped. So when we talk about parallel, you would just swap those words out. So in a parallel circuit, the voltages are going to stay the same throughout, and the currents will add up to the total. Okay, so remember that statement. It'll make more sense when we go over it right now. But notice how there's just a slight difference between the two. You're just swapping the words, swapping the blue and the red there. Okay, so let's look at a parallel circuit. So, a few notes about parallel circuit. First is the current. Current has multiple paths. So if we have now, let's say we have 1 amp leaving the battery now, well, this split right here is going to split up. Think of it as the current, think river current. When you have a big main river with parallel, that big main river will get split up into 2 smaller branches. So we have a branch of the river going through here and a branch of the river going through there. Okay, now I could make up numbers here. So let's just say that I had 0.3 amps went through this branch. Well, then the other one should have 0.7 amps, because then when they meet back up, all right, so you'd have the 0.3 going through here, you have 0.3 going through there. When they meet back up again over here, they need to add back up to the total current, which we know is 1 amp. And 0.3 plus 0.7 adds up to 1 again. Okay, now I made up those numbers, but they did have to add up properly. Okay, so there we go. Current has multiple paths. We know this already. You probably learned this from a long time ago. If one light bulb burns out, they all burn out. Or I'm sorry, they don't all burn out. If one bulb burns out, we still can have current going through the other resistor. So that's different than series, right? And you can think about that with Christmas lights. And you'll notice with Christmas lights, it's a kind of a mix now. Because with Christmas lights, if one bulb burns out, it won't be that they all burn out, but it also won't be that that's the only bulb. Usually there are strands that are parallel. Okay? Anyway, so there you go. So we know that about our about resistors. In parallel, if one burns out, the others stay on. Okay, the voltages will stay the same throughout. This is the key. So now let's go back to the example of 12 volts. So if I have 12 volts here, that means if you think about, you can think about that voltage going from the top bar here to the bottom bar there. All right? And you can think of it as a drop, as something falling. And what it means is that the difference in voltage from this side of the battery to that side of the battery is 12 volts. So that means on top here, the difference from this side, okay, to that side is 12. Okay, so if we have 12 volts difference from here, from the top to the bottom, everywhere on the top to the bottom, it would be 12 volts also. So if this is 12 volts, this will be 12 volts. That will be 12 volts. Okay, so the voltages stay the same with anything in parallel. Okay, now, the more paths we have, the less total resistance. So the last part is this, and my equation is missing my symbols. But here is my equation for now. If we want to redraw this circuit as one simple circuit, like that, okay? The way we would do that now is we have to use this equation. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and so on and so forth. Okay, so let's use different numbers here. Let's say that this is this has 3 ohms across this resistor, and this has 6 ohms across that resistor. All right, the way we would do our calculation now is we would have to do 1 over our answer is equal to 1 over 3 plus 1 over 6. Okay? So then what would you have to do? You have to do a little math, a little common denominator. Well, if I change this to if I got this as a 6, so I can multiply this by 2 over 2 over here. So I'd have 2 over 6 plus my 1 over 6. All right, is equal to my answer. So I have 1 over R total is equal to 3 over 6. Now, if I were to put my answer down, would I say my answer is 3 over 6 or 1/2? No, that's not the case. Okay, what I would have to do is I would have to flip it. Okay, so then my final answer is, basically you do the reciprocal of it, or you could do a little cross multiplying, but basically our total is equal to 6 over 3, or 2 ohms. Okay? So that's how our total works. And I'm going to show you shortcuts down the road, and I'll show you really easy ways to do it in your calculator that you won't have to do that kind of fraction math. But that's how it works. Notice that my new resistance is 2 ohms. So I have only 2 ohms now, would be if I recreated this as just one simple circuit. Well, that's less than my 3 ohms or my 6 ohms. So they don't add up. More and more resistors in parallel actually give you a smaller total resistance instead of a bigger one. Okay? All right, so we'll have plenty of practice with that as well. Now, let's look again. So again, the equation, what I just talked about. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on and so forth. Okay? And again, that doesn't mean the answer is 1 over R1 plus 1 over R2. 1 over the answer is, and you always have to flip it afterwards. All right. So once again, a reminder, voltages will stay the same. So if I have 12 volts across the battery, that means I'll have 12 volts across each resistor as well because they're in parallel. All right. And now let's talk about current. Now, current is going to split up, and we talked about that already, right? So the current's going to get split up. So in this case, if I had 0.4 and 0.6, they would add back up to the 1, okay, like small branches. All right, so once again, notice in a parallel circuit, the voltages stay the same throughout, and the currents add up to the total. All right, last thing I just want to mention is this. Your house is wired in parallel, okay? In the United States of America, we are wired in parallel with 120 volts AC. And that's good. That's an important thing, right? Because that means we don't have to have everything plugged in at the same time. That also means that when we plug something in, we always know we get 120 volts. If we had wired something in series in our house, there would be no guarantee what kind of voltage we would get. Because every time you plug something new in series, those voltages get split up because they have to add up to whatever the total is. Okay? Now, what about the other part of it? If you're in your house and you wire a bunch of stuff onto one circuit, let's say you're in one room, let's say you're getting ready to go out for the night, right? So you're in the bathroom and you got the hair dryer plugged in, you got your curling iron plugged in, you got a stereo because you want to listen to some music, you got a toaster oven because you might want a hot pocket when you're getting ready. All these things plugged in, you can consider resistors. And more resistors getting wired in parallel is going to get you a much, much smaller total resistance, a smaller equivalent resistance. And if we know the equation is Ohm's law, V equals IR, okay? So that means current, I, is equal to V divided by R. Well, if I get a smaller and smaller total resistance, so if my total resistance down here gets smaller and smaller, okay? My total current, think about what's going to happen. I'm going to get a bigger and bigger. If I have a smaller and smaller number on bottom to divide, I'm going to get a bigger and bigger current. The bigger current you have running through your house, there's a bigger chance of a fire. So that's why you have a circuit breaker. The circuit breaker, if you plug a lot of things into one circuit in your house, a lot of resistors in parallel, and you start getting a lot of current running through that wire, if it gets to be too much, the circuit breaker is going to pop so that you don't have a fire, or you don't have that wire overheat. Okay? So that is a little real life example, and that's something that you should go check out in your house. Go to the circuit breaker. Look at the numbers. The numbers are going to be the amount of amps that can run through that circuit. All right, ladies and gentlemen, thanks so much for watching, and I'll see you next time. Boom!